castle where the digital dreams come alive. CESCG takes place from May 1 to 5, from visualization to the virtual space. Scientific sessions take
Hello again.
their
So let me
place.
start the second track for today, the medical imaging, and we'll start with the first speaker, Erika Václavová.
Okay. Hi, my name is Erika. I'm from Slovak Technical University, and today I would like to present to you my UX research topic, which is domain expert in the loop of digitized histopathology education and artificial intelligence. As you can see, the title is a bit long and contains a lot of terms. So let's zoom in and find out how the cooperation between AI and histopathology education can work. So first of all, it's really important to mention that our research is in cooperation with domain experts from histopathologic field. And we found out that some of the processes are really old-fashioned and unnecessary time-consuming, especially when we are talking about observing the specimens. As you can see on the slide, the specimen is a sheet of glass with really thin and small piece of tissue with special chemical coloring. As I mentioned, it's observed by microscope. The digitalization of histopathology streamlines this process of analyzing tissues and converting them to the digital images by wall slice imaging. It's a digital pathology technique that involves scanning the entire glass slide by special scanners, as you can see on the slide. And the result is a digitized image with really high resolution. So this type of images enables easier storage, sharing, and better analysis of the specimen, and enhancing the diagnosis and research capabilities. It's really important for students to engage with this form of histopathology, so the digital histopathology will become their standard in their future work. To enhance this study process for these future medicines, we designed the user interface for AI-infused annotation tool in histopathology domain, and we designed it because we want to do the study process more flexible, faster, and more attractive for students. So it's really important to know about this tool. It's really important to know two things for this understanding of this tool. The first is the annotation itself, and the second is the loop, how the cooperation between AI and domain experts works. So what is the annotation? The annotation is a process of marking or highlighting the area of interest in specimens. As you can see on the picture, there is some tissue which we have to observe. When we find some area of interest, we mark it down. And after that, if this marked area refers, for example, to tumor, we set the class as a tumor. Annotations are crucial for creating datasets for AI training, and also his annotations enables more practice diagnosis and calculation in images, which was not possible before the digitalization. And the digitalization brings advancement in medical diagnosis and treatment. So for a wider overview, we can look around in the state of the art in digitized histopathology. On the left side, you can see the Human Protein Atlas, which is mostly the database with big amount of digitized specimens. It contains some predefined annotations and also some comments. You are not able to move in these images by yourself, but only in predefined paths or by clicking on the annotations. Also, you are not able to create your own annotations, and also you are not able to upload any of your own images. In the right side, we can see the AMBOSS system. It has some common things, that it contains a big amount of digitized data with predefined annotations, and it also contains a lot of study materials for future medics. you can't also upload your own images and create your annotations. And one disadvantage is also if you want to access these study materials, you have to pay the subscription. If we are talking about annotations, it's really important to mention the Cupid annotation tool. It contains various functionalities for annotations, but nonetheless, from UX perspective, usage of this tool is not really user-friendly, mainly for target audience with limited computer literacy, for example, the domain experts from medical field. We form our contribution into 4 main points. So the first is a design methodology, which we specified for specific domain experts, and we applied it to the whole collaboration. The second is the UI, which we designed after the observation, and also we tested it. The third point is increase acceptance of IT laymen to use the digitized tool during the histo-education process by the mentioned tool. And the fourth is the increased efficiency when working with digitized specimens using AI-infused annotation tool, as I mentioned, and also by correct AI result representation to this end user. As all points from our contribution were about domain experts, we have to work with design centered on the domain expert, and also it's really important to consider all stakeholders of this design methodology. These stakeholders are the domain expert, the user experience experts, and the technical domain. During the system development process, the domain expert generating the data, and the system or technical domain provides the data in understandable form. The presentation format of the data is examined by user experience experts or UX experts, and also the UX experts explores how to create a reliable and usable system. It's really important to mention that the UX experts communicate with domain experts in the field of medicine, and if these people from medical domain have some findings, they are translated to technical domain by user experts. So, it's really important to grasp the cooperation correctly from the initial phases to achieve the satisfaction for a domain expert, and we can do it by this path, which we design. The first half of this cooperation ends with creating the mental model. To create the comprehensive mental model, we have to do observation of works, needs, and limitation of domain experts, and it's really important to visit their home environment and observe them in their daily job and see their behavior and the workflow without any bias. After that, we can fully understand the mental model. The second half of these phases starts with the most important part, which is trust. It's really important to build the trust between domain experts and technical domain due to significant differences in focuses. We have to build the trust gradually by openness and dialogues, and we have to get to the point when domain expert gains the confidence and begins to collaborate with technical domain as with colleagues without any need to distinguish or underestimate either side. After that, we gain the trust. It's necessary to reinforce this trust by involving the domain experts to the development process or in designing process by making it clear that the ideas of domain experts are also important in technical domain. And the results contains everything what we need from a cooperation, the system, the prototype, but from UX perspective, we're talking about the most important result, which is the satisfaction of domain expert in field of medicine. We designed one of these tools, as I mentioned, the annotation enhanced education tool. Comparing to existing tools, at first glance, it looks really simple, but it's minimized only for the needs of these domain experts, so it's simple for purpose. So we designed this annotation tool with extra functionalities driven by AI, and these functionalities were tested by users. And this tool will help the students get practice in annotation in field and better understand the specimens in digitized histopathology. So we ran through the usability testing, we tested the tool, and all participants was asked to do a task that please annotate the endocardium of the specimens. For people who are not from a medical domain, it's something similar as please mark the flowers on picture on the art. The participant group was made up from domain experts with various level of expertise, and the task performance was in 3 options: by do it manually, do it with annotation proposal, and do it with automated annotations. The before mentioned functionalities presents the form of AI implementation. The augmentation assists the user, but the final decision is on the user themselves. The augmentation shows the annotations one by one, and the domain expert decide if the annotation is right or not by rejecting it or accepting it. The automation shows all annotation at once, and the responsibility of checking all of them on the specimen is on the domain expert. We compared the usage of these functionalities and the annotation with participants, and we found out after testing that the fastest way to do all annotations or on specimen is by automated annotations. As you can see, it takes a bit more than 59 seconds. And also, as you can see on the table, there is a big difference between annotating without AI and with using AI tools. The second thing, it's really important that there is some relationship between domain expert expertise and the level of benefits from using this AI. Before I mentioned that the fastest way to do all annotation is by automated annotations, but it's not really beneficial for user with lower level of expertise. Sorry for that. The reason is that the domain expert with higher level of expertise can critically evaluate the results of AI, whereas without domain knowledge, there could be negative influence on the outcome of AI. As you can see on the graph, the purple curve starts on a higher point. It means that the augmentation is more suitable also for domain experts with lower level of expertise, but by implementing the things like some recommendation or helping the orientation in digitized specimen. So for the end, in conclusion, artificial intelligence speed up the annotation process, but it's really important to mention the functionalities driven by AI depend on the level of expertise of domain expert, and it's also very important from UX perspective to grasp the collaboration correctly from the initial phases. In our future work, we plan for medical faculty students to adopt the annotation tool in their education process and do an extensive usability study while evaluating their interactions. The study of interaction will supplement the study of design focus on domain expert in field of medicine. So thank you for your attention, and if you have some questions, I'm happy to answer them.
Thank you, Erika. So maybe you have some questions from the audience. Yes.
Okay, thank you very much for your nice presentation. I want to ask about this graph. Like, what are the benefits? It's just the time they spend annotating, or is there some other evaluation considering like precision of the annotations, whatever?
Okay, so all students are studying from this creating the annotations, and they're creating some diagnosis from the specimens. So if we are showing them the annotations as the recommendation that please look at this part of the picture and try to find some interesting area, it make a more educational thing than showing the automated annotations for whole specimen, because they have the place to think about it, and also they are not influenced by maybe from the wrong annotations. If you understand.
Okay, but how is this measured? Like, what is the y-axis of this graph? Like.
Okay, so these benefits are mostly about things what they got in study field, it's not measurable in conclusion as with number.
Okay.
So it's qualitative measure.
Okay, by some questionnaires?
Yeah, by questionnaires and interviews and communicating with our domain experts.
Okay, thank you very much.
Maybe some other question from the audience?
So I wanted to ask a question about, so you were showing the table about speeds, right? So, and you have some questionnaire results, so is the speed of the people using this or the time that is required somehow correlated to their level of learning that they get based on the outcome of the questionnaire? Because you showed the data, right? And to me in the presentation it was not clear that you're showing results in terms of time to process it, but the point is to educate people. So it's not clear to me whether doing something faster means you learn more or something. So is that correlated? How is that related to the educational outcome this time that you have there?
I understand your questions. Yeah, the time is really important in way of creating the data or the data set, but in the learning curve, for example, most of the students choose the options of automated annotations, but after consulting with expert, so with, for example, with teacher, we conclude that it's not really beneficial form to show them all annotations. So it's one thing that is the fastest way, and the students or the level of experts with lower level of expertise choose this opportunity to use the automated annotations, but in education purposes, it's not really beneficial for them by these evaluation, not only measurable numbers. So we compare the thing that, okay, we would like to choose the fastest way, but it's not the best way to present them in some educational tool.
Thank you.
Maybe some last question?
So, thank you. Making sure I've understood your explanation for the past thing is that if we look at this graph that we have displayed on the slide now, and we think of the benefits as the benefits for education purposes, then the purple line, which now starts above the blue line, should actually start below the blue line when they have less expertise and then cross it. Is that what you meant by your explanation, that for teaching in the beginning it's not helpful to show them all the automated annotations?
It's true.
Okay, thank you.
Okay, so thank you very much, Erika, once more.
Swim to the beach where the pixels play, from rendering to VR, it's a pixel away.